These problems come from a handout titled Customary Units of Measurement. And we'll come up with two different methods to solve these problems. So what I did for you is I wrote down the chart that is in the textbook, and this chart is on page 250. So if you ever go to page 250 in the blue textbook, you'll see this exact chart. And we'll need this to be able to solve these problems. So we've got two different methods. The proportion method is one where we set up a proportion, which is two ratios set equal to each other. And the way it works is this. We start with what we have, 13 yards, and we write that down. Now, I typically like to use the units in my proportion to start with, because when we're writing proportions, we try to get the same units in the same location, or at least we're consistent with the problem. So 13 yards over, and then we have to come up with the number of inches. So I don't know the number of inches yet, so I'm going to put X inches. So that's what we're looking for. Now we need to write a unit conversion, a scale factor for yards to inches. So let's go over to weight, because that's what we're in here. I'm sorry, distance, length. And we are talking about yards. Well, there's 3 feet in 1 yard, but we don't want feet, we want inches. So there's 12 inches in 1 foot. So what we need to do is we need to figure out how many inches are in 1 yard. Well, there's 3 feet in 1 yard, 12 inches in 1 foot. So if we take the 12 and multiply it by 3, basically 12 plus 12 plus 12, but instead of doing that, we can multiply the two numbers and get 36. So there's 36 inches equals 1 yard. So it's something we had to come up with on our own there. And that's the difference between the proportion method and the multiplying method. For the multiplying method, we don't need to do this extra work. So let's go ahead and plug that number in there. Again, we want the yards on top because we have to be consistent since we're dealing with a proportion. And we'll put 36 inches down below. And so from this point, all we have to do is that cross multiplication. So we're going to multiply the numbers diagonal from one another. So we have to set up 13 times by 36 and set that equal to 1x. So at this stage, you don't need to worry about those units. The units just help us out making sure that we get both yards on the top of the fraction, inches on the top or the bottom of the fraction. So we're just being consistent when we're setting it up. So from this point, we multiply those two numbers, 13 times by 36. We end up with 468. So what does that represent? Well, let's go back into our proportion here. X is in inches, and that's what we wanted to find. So how many inches are in 13 yards? That's the number. Well, we can come up with the same answer using this multiplying by 1 method. So let's go ahead and set this one up. So with the multiplying by 1, we do sort of the same thing. For the first part, it's 13 yards, but instead of over X number of inches, it's just over 1. So we just treat that number as a fraction. And the reason why we're doing it is because we're going to end up multiplying by 1, but we're going to try to cancel out the units as we go. So here we go. We take a look at how many yards there are, and we can, instead of going directly to inches, we can go from 1 unit to the next. So we can go from 1 yard to 3 feet. Okay, 1 yard equals 3 feet. This is a factor of 1, and when I do the division, so what I want to do is I want to cancel out the yards. So I'm going to put 1 yard down below, and I'm going to put 3 feet on top. And you see what ends up happening here is that the yards will end up canceling out. And the reason why I can do this is because this represents 1. See, it's just a unit fraction. It means it equals 1. 3 feet equals 1 yard. So 3 feet over 1 yard will equal 1. So I'm not changing the value of this 13 yards. I'm just changing it to an equivalent fraction. So let's take a look at the next part. We're still not done. See, we're in feet. Now we need to cancel out feet. So I'm going to times by another factor of 1. But this time I'm going to cancel out feet. So I want feet on the bottom. I want 1 foot on the bottom. And how many feet are in, or how many inches are in 1 foot? 12 inches it says. So I put 12 inches on top, and we'll end up getting those feet to cancel. So again, this is another unit rate. So this is a value of 1. So I put this giant 1 up here to show that, convey that message to you that this is not changing the value of 13 yards. It's just changing it to an equivalent fraction. So now we get those feet to cancel, and we're just in the units of inches. And so we've got our value there. So we go ahead and multiply those numbers, and we get the same answer. 13 times 3 times 12. Well, 12 times 3 makes 36. See, we did 36 times 13 already. So it should come up with the same answer, 468 inches. Well, let's take a look at another one here. Same sort of thing. We're going to go ahead and use the proportion method to start with. So we want to go 4 gallons to cups, and then also quarts. Well, it's easier to go to quarts to start with, so we'll do that first, and then I'll do cups. So I'll use my fraction right here, 4 gallons. And since we're in the proportion method to start with, we'll write down x quarts. Alright, so now we're going to set up another fraction, and it's going to be equivalent. So that means I need gallons on top and quarts on the bottom to be consistent. See, we're having an equal fraction here. And so let's take a look at how many quarts are in a gallon. So we got to go to capacity, and there's 4 quarts equals 1 gallon. So I have 1 gallon per 4 quarts. Alright, well, all we have to do there is cross multiply. Multiply these two numbers here, and then these two values here. And so now we don't have to worry about the quarts and gallons. We just need to deal with the numbers. So we have 4 times by 4 equals x. Well, that was easy. 16. 16 equals x. What's x? X is quarts. So 16 quarts. So we figured that powdered out. 16 quarts. I guess we should put up our 468 on the other one. Alright, well, that's going to quarts. Now let's go to cups. So let's do the same thing. We got 4 gallons, but this time we want x. Let's use a different variable. Let's use y this time. Y cups. So I'll write out cups since I'm dealing with a variable in there as well. And equals. Okay, now I'm going to set up my same proportion, same ratio, so it needs to be in gallons over cups. So let's figure out how many, what the units are. Well, 1 gallon. How many cups are in 1 gallon? Let's go to the chart here. 4 quarts in 1 gallon, 2 pints in 1 quart, 2 cups in 1 pint. So we have to multiply these numbers. So it's going to be 2 times 2 times 4. So I'm multiplying all these numbers because I need to go all the way to cups. So 4 quarts, and then 2 pints and 2 cups. And then I'll get to cups. And so when I multiply all those numbers, 2 times 2 is 4, times 4 makes 16. So 16 cups it's going to take in order to get 1 gallon. So now we can go ahead and cross multiply. Let's multiply those numbers diagonal from one another, and we'll get our answer. So 4 times 16 equals, and then we have this, y times by 1. So 1y. So we go ahead and do that multiplication. 64 is what we get. So what's that represent? Cups. So there it is, 64 cups. Well, there's another way to get those same answers. So let's take a look at that. It's the multiplying by 1 method. So that works this way. You take 4 gallons, and instead of writing it over x quarts or x cups or y cups, you write it over 1. And we're multiplying by a fraction. So when we multiply, here's where we want to cross cancel. So we want to put gallons down below to get those gallons to cancel. So we start with quarts, and then we take this unit, this scale factor here, or this factor of 1, these measurements here, and we write that as a fraction, 4 quarts over 1 gallon. And so right away we get our first answer here. See how these gallons will cancel? We get the first part. 4 times 4 makes the 16 quarts. Well, we have to continue to go further, so now we go to 2 pints is to 1 quart. So we go ahead and do the same thing. So we've got 2 pints to 1 quart. Well, we want to put the quart down below because we want that to cross cancel here. So put 1 quart down here, 2 pints up top. Alright, well, we're still not done because we need to go to cups. Well, we put the pints down below because we want those to cross cancel, and we put the cups up top. Well, how many cups are in a pint? It's 2. So then from there we get our cups, which is what we want. And we go ahead and multiply all those numbers, we get the same answer. 64 cups is the value of 4 gallons. Well, let's take a look at one more problem here. we've got another proportion to set up. This time we are in a weight. We're at 3 3/4 pounds, and we're going to ounces. So let's call it XOZ, X ounces. All right, let's set up our next ratio, and when we do this, again, we want the numbers in the same location. See, since we're equaling this time, it's a line equals sign line problem, it's a proportion, we need to make sure that we have those same units in the same location, or we just need to be consistent. So let's take a look at the unit conversion here from pounds to ounces, or ounces to pounds. It's 16 ounces is to 1 pound, so that's what we'll write. 1 pound is 16 ounces. So we're ready to solve. See, there we have it. We've got our cross multiplying. We're going to multiply these two numbers, and then after that we'll multiply x and 1. So here we get x times 1 equals 3 3/4 times by 16. Ooh, this seems kind of tough. We've got a fraction here. So what we want to do is we want to convert this into a improper fraction. So 3 times 4 plus 3. So I'm doing the whole number times by the divisor plus the numerator. And that gives me a 3 times 4 is 12 plus 3 makes 15. So 15/4 multiplied by 16. Now, how do I treat 16 as a fraction? 16 over 1. Well, from there we do some cross canceling. We got 4 into 16 goes 4 times. And then we got some multiplying to do. 15 times by 4. And that gives us 60. So x is 60. So 60 ounces is what we end up coming up with there. So that's our answer. But let's take a look at the other method real quick, just to practice that. And so it would work this way, 3 3/4. And we're in pounds. And so we want to cancel out pounds and get to ounces. So we're going to write that as a fraction, and then we're going to write the conversion factor. The conversion factor, we want the pounds to cancel. So now we put the pounds diagonal because we want those to cross cancel. And then we put ounces on top. Well, there's 16 ounces in 1 pound. That's what the conversion factor says up here. So from that point, we could go ahead and do the cross canceling. So see how the 16 or the pounds end up canceling? So we're left with the 3 3/4 times by 16. We've already done that. 3 3/4 times by 16, we saw before, that was 60 ounces. So there it is. Two different methods to solve the same type of problem. One is using proportions. The key on proportions is you want to be consistent. You want a fraction that's equivalent to another fraction. So we have to have the same units in the same locations. Multiplied by 1, we use this conversion factor as a factor of 1, which helps us come up with a similar fraction, but not quite the same. And so here's my version of 1. And so if I shrink this down, you see a little better. And we're multiplying this 1 by a number. So we're not changing the value of the number, we're just changing the type of fraction it is, and we're making it an equivalent fraction. So those are some problems on tonight's handout. Good luck.